Hello all, welcome to video lecture series on smart system design. Myself, Dr. C.H. Rajendra Prasad, Professor, Department of ECE, SR University, Warangal. In this lecture, I am going to discuss about liquid crystal display interfacing with Arduino Uno. LCD stands for liquid crystal display, and first we need to discuss features of LCD one by one. LCD operates with 3.3 volts or 5 volts, and it is an alphanumeric display. That means it can able to display all alphabets as well as numbers with the help of this CG-ROM. CG-ROM stands for character generator ROM, where all characters ASCII codes are accepted by the LCD, and a particular pattern is generated in order to display the corresponding character. And next feature is LCDs are available with different sizes. You can see here 8 cross 2, 12 cross 2, 16 cross 1, 16 cross 2, 16 cross 4, 20 cross 2, 20 cross 4, 20 cross 2, 24 cross 2, and 40 cross 4. These are the different sizes of the LCD, where the first number represents the number of characters in a line, and second number represents the number of lines. So that means 8 cross 2 means 2 lines, and in each line 8 characters are available. That means total 16 characters are available. It can able to display. And then each character is built by a 5 by 8 pixel box, and can work on both 8-bit and 4-bit modes. We will discuss in coming slides how it will be operated in 8-bit mode and 4-bit modes. Then it can also display any custom generated characters. In some cases, user requires some custom generated characters. In that cases, we will use the CG RAM. Within the CG RAM, we need to store corresponding custom generated character. Here, CG stands for character generated random access memory. And LCDs are normally available in two different backlights. One is green color, another one is blue color light. And the current consumption is 1 milliamps without backlight. These are some of the silent features of LCD. Now, let us discuss the features of pins of the LCD. Before discussing the pins, let us see first how it can able to display a character. So if you observe here, the LCD is having 4 lines. Line number 1, line number 2, line number 3, line number 4, and each line there are 20 characters are available. So that means the size of the LCD is represented by here 20 cross 4. And next one, if you observe second one, in this second LCD, there are 16 characters are available in first row, 16 characters are available in second row. So this is 16 cross 2 LCD. 2 lines, in each line 16 characters are available. Then we can represent it as a 16 cross 2 LCD. And if you observe here, this LCD is available with a backlight of green color, and this is available with a backlight of blue. And we all already I mentioned in previous slide, with the help of CG-ROM and CG-RAM, the user can display the alphabets as well as numbers and some custom generated values or custom generated graphics. So let us see how a character will be displayed on LCD. So now if you see here, our each character is represented by a 5 by 8 pixel box. 5 by 8 pixel box. And if you observe here, in order to generate a character A, so the green color dots need to be enabled and the remaining dots should be disabled. So for this, within the CG ROM, this pattern is already saved. That means if you want to generate this pattern, the user has to send ASCII code of character A onto LCD. Once you are sending this ASCII code of onto the LCD, then it will goes to that RAM and it will generate the pattern. Similarly for B, C, and so on. So in this way, a character is displayed on LCDs. And let us see the pin diagram of LCD now. If you observe here, there are 16 pins are available on the LCD. They are VSS, VDD, EE, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, LED anode, LED cathode. These are the 16 pins of the LCD. Let us see one by one. We will discuss the operation of these pins. If you observe here, the first pin and second pin are the power supply pins of the LCD. These are power supply pins of the LCD. The first pin is VSS. It is also known as ground, where we need to apply 0 volts. And on second line is the VCC or VDD, where we need to supply 5 volts or 3.3 volts. These two pins are power supply pins. And next pin is the V0 or VEE. This is normally used for contrast adjustment on the LCD. Then next three pins are configuration pins, 4, 5, and 6. These are called as configuration pins. The fourth pin is RS. RS stands for resistor select. RS is equal to 0. The LCD will receive the commands, and if RS is equal to 1, the LCD will receive the data. So let us see now what is the meaning of command and what is the meaning of data. Suppose if you want to display something on the LCD, suppose let us consider LCD interfacing. This is my data. If I need to display this LCD interfacing, this is called as a data. But some cases, the LCD are available with different sizes, and I need to display this LCD interfacing. So that means I need to instruct with the help of some commands. So that means we need to use the commands. So that means we can send the commands to LCD in order to display at a particular position or at a particular position as well line number. So that means these are called as commands. Then read or write bar. Read or write bar. Next line is the fifth line is the read or write bar. If read or write bar is equal to 0, means write operation. That means The LCD is accepting the data. Read or write bar is equal to 1 means read operation. Read operation is nothing but we are reading the status information from the LCD. So normally we won't read the status information, but most of the cases we will use read or write bar is equal to 0 only. And then sixth pin is the enable pin, the clock enable. This is always enabled during LCD is always enabled using falling edge of this enable signal. So we need to provide 430 milliseconds of a low level signal under falling edge of this enable signal only. The LCD will be enabled. And one more important thing, this enable signal saves the power of the LCD, power consumption of the LCD by disabling the data bus. The LCD is having 8-bit data bus. So whenever it is connected to any microcontroller or any device, it is always trying. This bus is always trying to draw the current from the source. So that means your for battery operated systems, it is automatically uh, increases the power consumption. In order to relieve the system from this burden, normally we will enable or disable our data bus during whenever it is used. We will enable that data bus. Whenever we are not using, we will disable that bus. So that's why this enable signal is provided on the LCD. Coming to data bus, these are from 7 to 14. These lines are bidirectional data bus. They are represented with DB0 to DB7 or D0 to D7. With the help of these data lines, we can send the information, that means messages, data, as well as commands to the LCD. And similarly, we can, while reading, these lines are used to read the status information from the LCD. And uh, finally, we are having last two lines. They are 15th line and 16th line. The 15th line is LED anode and another one is LED cathode. These two lines are optional. These are used whenever the ambient light is based on the ambient light. The display may not be visible. So in that cases, we can use this backlight LED. There are two lines are provided. One is LED plus and LED minus. On LED plus, you need to provide a voltage in between 1.8 volts to 2.2 volts. And LED cathode, LED minus means LED cathode. On LED cathode, you need to connect to ground or 0 volts. Then we need to discuss one activity on this LCD. So let us consider activity 2 in this lecture. Design a smart system to display RP EduTech in the first line of LCD and YouTube in the second line of the LCD. Let us see first what are the components needed to implement or to design this system. So first we will list out one by one. So first we need a personal computer, a laptop or a mobile phone. Then Arduino software is needed. Then Arduino UNO board is needed. Then universal serial bus cable is also needed. A breadboard for making the connections and some connecting wires. These are the common components which we require for most of the applications. But for this application, we need a LCD. And one more important thing we need to remember here, when you are using a LCD, it is having a backlight. So to connect the backlight, we need a one resistor. Backlight is nothing but it is a LED. So this, sorry, LED. LED, we require a 220 ohm resistor when you are directly connecting to Arduino Uno. In addition to this, we require one potentiometer which is used to adjust the contrast of the LCD. So that means the additional components required for this application is here liquid crystal display of 16 cross 2. Why I'm taking here 16 cross 2? Because here my character size of this message and this message is limited very less. So that's why I taken only 16 cross 2 only. We can also choose other size, but it is suitable for this application. Based on our display requirement, you can go with the different sizes of LCDs. And another component is here 10 kilo ohm potentiometer is I am using here, and 220 ohm resistor is also used for this application. These are the components required for this activity too. Now, when you want to design any system, first we need to know schematic diagram of that system. First, we will draw the schematic diagram or circuit diagram. So for our application, first we need a Arduino Uno. Then we need a 16 cross 2 LCD. To power up this LCD, first we need to give the power supply. So I'm giving power supply for VDD, I'm giving 5 volts, and for VSS, I am connecting to ground. First, I am given the power supply. Then I need to connect V0 pin. V0 is the contrast adjustment pin. Under contrast adjustment pin, I need to provide the variable voltage. So to provide the variable voltage, normally we use the potentiometer. The potentiometer is having three terminals, and here the middle terminal where the slider is connected, the output of the potentiometer is connected to VE or V0 pin, and remaining other two ends, one end is connected to 5 volts, the other end of the potentiometer is connected to ground. After connecting this V0 potentiometer, then by changing the potentiometer knob, we can get the different brightness on the LCD. Then we need to connect the control pins. We already know that there are three control pins are there: RS, RW, and enable. So RS is a signal which requires either 0 or 1. That means on Arduino, we need to connect to any digital IO pin. So I'm connecting, and similarly, enable pin is also falling edge. Falling edge is nothing but high to low pulse. So that means it is also a digital signal. So that means I am taking second pin and third pin as digital pins and connecting to RS pin and enable pin of the LCD. And then in this application, I am not reading any status information from the LCD. That means I am not reading any data. So RW pin should be connected to ground. So I am using only write operation. Write operation is nothing but I am always sending the data to data or command to LCD only. So that means RW pin should be connected to ground only. Once RW pin is connected to ground, then we need to connect data bus. So data lines D0 to D7 lines. But these D0 to D7 lines are operated in two different modes, 8-bit mode and 4-bit mode. So in this application, we are going to use only 4-bit mode of operation. So in 4-bit mode of operation, we normally will use D4 to D7 only. Okay, so D4 to D7 pins. And D4 to D7 pins normally require binary information. So I'm considering fourth pin of the Arduino, fifth pin of the Arduino, sixth pin and seventh pin of the Arduino. These lines are connected to and D4 to D7 lines of the LCD. Once these are connected, We are ignoring D0 to D3 pins. Why? Because here I am using only 4-bit mode of operation. So in 4-bit mode of operation, I am using only D4 to D7. These lines are tied to 4, 5, 6, and 7 of the Arduino. And there are two optional pins are also available. They are LED anode and LED cathode. If you want to connect, you may connect. So that means already as per our requirement on LED anode, we need to connect a resistor of 220 ohm size, and another end of this one should be connected to 5 volts. So then here the resistor consumes almost 3 volts. 2 volts will be given to LED anode, and LED cathode should be connected to ground. So this is the complete schematic diagram of our application. That means interfacing of 16 cross 2 LCD with Arduino Uno. Now, once schematic diagram is completed, then we need to write the sketch for our application. Already we know that our application is in first line of LCD, we need to display RP EduTech, and in second line, we need to display YouTube. So for this, I need to write this sketch now. To write this sketch, first and foremost thing is we require actually setup and loop functions. And one of the important thing here, when you are using LCD, the Arduino is already providing some inbuilt libraries. So for LCD is also, it is providing some inbuilt library that is named as liquid crystal.h. So first I am using that library only. So when you are using a library, first you need to include that library. So here I am including the library with the help of hash include liquid crystal.h. And one more thing you need to remember here, L and C should be capital for this library. Once you include any library, then we need to define a class for that library. Here that library class is liquid crystal, and user defined name you can give here LCD, or any other name you can give here LCD. And the parameters are whatever the pins you are used for RS, enable, D4, D5, D6, T7. As per our circuit diagram, I used RS pin for second line and enable pin for third line, D4 pin for fourth line, D5 pin for fifth line, T6 is for sixth line, T7 is for seventh line. So whatever the pins you are used for um, LCD, that should be represented here in the form of RS, enable, D4, D5, T6, and D7 in the sequence only. Then once you define a class, then you can write this setup function and loop function. So within the setup, we need to normally initialize our board. But already we are used LCD library, crystal library. Then there is no need of define all those pins. Instead of this, there is a one command is provided. That command is called as begin or function. Instead of a command, we are call it as a function. Why? Because this function will configure all these pins according to input output requirements of our application or LCD requirement. So here I am using LCD.begin, which will inform the Arduinos that it is a 16 cross 2 LCD. Why? Because I am used here the size of the within the parenthesis we need to represent within the parenthesis as a parameter we need to send the size of the LCD. So the size of the LCD is 16 cross 2. So, but we here in this command, you need to represent as a 16 comma 2 only. So once it is completed, our setup is completed now. Once our setup is completed, we need to write our mm, actual application. In our actual application, we need to display YouTube channel RP EduTech in first line and YouTube channel in second line. So now let us see now. We need to select the send some commands in order to initialize our LCD. Where we need to display in first line, I am going to display first message, and in second line second message. So in order to select this, we are having a one predefined command that is called as lcd dot set cursor. So I am using lcd dot set cursor. Here you can see in under set cursor, C is capital, and there are two parameters are provided. The first parameter represent the position in the line, and the second parameter represent the line number. So it is 0 means line 0, and this is position 0. So based on our requirement, you can change these numbers, and then we need to print our data. So to print our data or to send our data onto LCD, we need to write LCD dot print. So here actually EC is available. We can replace this EC with our RP EduTech. So and let us now RP EduTech, and then once it is displayed in the first line, it is displaying ECE. And one more important thing here, you can remember here, whenever there is a double quote, it is a string. The string is displayed directly on the LCD. If you remove this one, whatever the contents on the ECE is now treating as a variable. If you remove the double quotes, now ECE is treated as a variable. But now it is a string which is displayed directly on the LCD. And then selecting second line, we need to use lcd.setCursor, where I'm again I'm using position is 0 only, but the line number is 1. Okay, this is line number is 0, this is line number is 1. So two lines. In first line I am printing ECE. In second line I am printing SSD. SSD is in place of SSD as per our problem statement. I need to represent here YouTube. So any message you can send. So here ECE and here SSD. That means we are sent two messages. One is ECE onto first line, another one is SSD onto second line. And one more important thing, after sending any data or comments, we need to give some time for the LCD to settle down and to display. And why we need to give some time? Why? Because most of the time the controllers, microprocessor, Arduino, they are operate with very high frequency. That means the speed of operation is very high as compared to peripheral devices. Peripherals are nothing but input and output devices. Our LCD is also one of the output device where it takes some time to settle down. So for that, we need to give some small amount of time with the help of a delay function. So here I am using delay 200. 200 means 200 millisecond. This is commonly used delay for LCD. So from this, we completed our sketch. In this sketch, just I first included the liquid crystal.h library. Then I defined the class, and I'm given a name for my class is LCD. We can also give any other name also. And the parameters are based on the schematic diagram. I used second, third, fourth, fifth, sixth, and seventh pin based on the sequence only. And then within the setup, I defined the size of the LCD 16 cross 2. Why? Because I used in the schematic diagram, I used 16 cross 2 only. And then within the loop function, I written actual code. First, I selected position 0 and line number 0, and I entered the message EC in first line from first position, and then I set the cursor position to second line. So 0th position and second line is selected. After that, I sent the second message, that is SSD, and after that I am given the some delay in order to settle down the LCD. And this is the sketch for our application. Then we need to discuss some of the options or functions which are useful for you whenever you are interfacing LCD with Arduino Uno. So first, we'll see some of the commands provided by this library, liquidcrystal.h. No display. This function turns off the LCD screen without clearing its contents. Sometimes we need to save the power. So whenever there is no person is seeing and there is no uh, information is not required, in that case we can go with turn off the LCD without clearing its contents. So we can use this command, no display and display. This command turns the LCD back on after no display was used. So previously we are used this no display. Then again we need to get back to whatever the display is available. So to get that data, so we need to use display. Then auto scroll. This auto scroll makes the LCD text automatically shift left as a new character are written, giving a scrolling effect. So it gives the scrolling effect, and it automatically shift the data left side whenever new character is entered. And one more important thing, this is used whenever we are using a dynamic data or long data. This is the main use of auto scroll option of LCD. And similarly, scroll display. For animated purpose, normally we'll use a scroll display. So here scroll display left and display right is available. So we can shift the data right as well as uh, left with the help of these two commands. Then cursor, which shows the underscore style cursor non-blinking at the current position. Suppose you are selected 0 and 0 position. At that position, it will gives underscore like type cursor non-blinking at that position. And similarly, no cursor. No cursor means the underscore is not visible. It hides the underscore cursor. And then blink. Blink makes the cursor on the LCD. Makes the cursor blink on the LCD. And stop the blinking cursor. Cursor is stops to blinking. And write is similar to LCD print only. Writes a character or byte to the LCD at the current cursor position. These are the some of the important functions. This may be useful while interfacing LCD with Arduino Uno. But coming to our problem statement, that is activity 2. Now we need to do a lab session on Tinkercad. So I'm clicking on this. Now We are moving on to Tinkercad for laboratory session. Then see here, we will see here. This is my login. In this login, first we need to go to new design and then circuits. Once we click on circuits, by default, it is giving a project name as some default value. So as per our requirement, we'll change this as activity 2. Our activity 2 already you know that we need to interface LCD to Arduino, and then we need to display uh, first message and second message. Our first message is RP EduTech, and the second message is the YouTube channel, YouTube. So in order to implement this, first we need to drag and drop our required number of components into workspace. This is the workspace already you know, and then I'm first taking Arduino from component list, and then I need to bring a breadboard. So I taken a breadboard now. Once you are taking breadboard, then you need to bring one LCD. After taking the LCD, so in this way you need to arrange. LCD requires more number of lines. So normally you need to use the breadboard. Let us make the connections one by one. As per our circuit diagram, we know that all the circuit connections. So first, when you are using a breadboard, in order to make the common VCC required for most of the components, you can use a common VCC and make it as red, and a common ground on the breadboard. So make it as black. So normally I prefer VCC is represented with red color, and black color is represented with ground. Now these lines becomes 0 volts, and all these lines becomes 5 volts. Now, as per our circuit diagram, we need to make the connections. To make these connections, first line, you know that is ground. This ground should be connected to, okay. So in this way, you can connect ground. After connecting the ground, then you need to power up the LCD. The second line is LCD. So where we are connected 5 volt supply. So now you can see here, the 5 volts is connected. V naught. So V naught requires a variable voltage in order to adjust the contrast. So we require a potentiometer. I consider a potentiometer. Like this, you can arrange a potentiometer. You can see the middle pin is the output pin of the potentiometer, wiper, and the remaining two sides represent the VCC or ground, or there is no polarity for the remaining two pins. So that's why I connecting this terminal to ground. So I'm making this line is black, and sorry, you cannot connect here. Why? Because already wire is there. So then this you can connect to ground, and this one you can connect to VCC. So that means there is no polarity. That's why I interchanged, no problem. Why? Because it is already uh, this dot is already occupied by VCC. Then Coming to RS, this RS pin should be connected to second pin of our Arduino. As per our circuit diagram, the RS pin should be connected to second pin of our Arduino. You can change the color if you want. I'm taking yellow now. RW pin is connected to ground only. So I am directly connecting to ground here. You can see here, this RW pin is connected to ground, and then enable pin is connected to hard line. As per our schematic diagram, I connected this into hard line. Then we need to ignore this D0 to D3 lines, and D4 line should be connected to fourth line of the LCD, and sorry, fourth line of the Arduino. D5 line is connected to fifth line, and D6 line is connected to sixth line, and D7 line is connected to seventh line. And in order to differentiate these data lines, so I'm using different colors now. I use blue whites for all data lines. Then after this, here this one also I am changing to some other color, purple color for enable, and here the output of the potentiometer also I am changing it to some other color, pink color. So now we completed most of the connections. Then finally we are having we left with only two connections. This is LCD anode and LCD cathode. This is anode, this is cathode. So on LCD anode, you can directly connect one resistor. So this resistor size should be 220 ohms, and this is not be directly connecting. So that's why I'll shift this LCD to downward. Now it is directly connected. So then LED cathode should be connected to ground. Okay. So from this, we completed our schematic diagram. Once we completed a schematic diagram, then we need to go to code, where first we need to use this text option only. I prefer text option. If you want, you can go with blocks or blocks with text. And based on our requirement, we need to write our code. Now I'll write the code for our application. So already we discussed. Anyhow, I'll write once again here. First, we need to include liquid crystal dot h. Then we need to define a class. So the class name is already, liquid crystal, and you can give any name for user defined name. I'm using here LCD, and the connections. As per our connections, we need to see RS is second pin, Enable is third pin, and D4 pin is fourth pin, D5 is fifth pin, D6 is sixth pin, D7 is seventh pin. So in this way, you need to connect the line. The parameters 2, 3, 4, 5, 6, 7. These are the pins already we are connected within the schematic. Then in setup function, we need to use LCD at begin. LCD, whatever the name you are given here, that should be before the dot of every command, every LCD command. Here LCD dot begin. So within the begin, first we need to define the size of our LCD. Our size is 16 cross 2. So that's why I need to represent 16 comma 2. Then our setup function is completed. So within the loop, we need to provide first we need to select the line number 1. To select the line number 1, LCD dot set cursor we need to use. Set cursor. Then within this parameters are 0 comma 0. This 0 represent the position and this 0 represent the line number, first line. And similarly, we need to write LCD dot print. This print is used to print a message on LCD. Our first one is first message is Happy EduTech, and which should be within the double quotes only. Then only it will be treated as a string. And then you need to copy the commands. Why? Because I need just a simple modification here. So I need to select second line. Sorry. For selecting second line, we need to use 1 here, 0, and this is 1. 0 means line number 1, line number 0, and 1 means line number 1. And here our message is only changed. That message is YouTube. Then we need to provide some delay. So normally we'll prefer 200 millisecond is enough for LCD to settle down. So 200 millisecond delay is provided. Once it is completed, then just you need to start the simulation and close the code window. Now you can observe here, RP EduTech is available in first line, YouTube is available in second line. So suppose, for example, if you want to change the position of your message, so what are the modifications we need to do? Let us see now. Suppose, for example, if you want to change the position, whatever the position you require, from that position we can print your data. So here also you can change the position from 5. Now you can start this. And close the code. You can see now. If you are given E, so then where it is displayed, 0th position, first, second, and third. From third onwards, it is printing. And similarly here also, we are placed 5. So 5 means 0, 1, 2, 3, 4, 5. So from fifth position, it is displayed. Sometimes you may scroll your display. Auto scroll. Auto scroll option is available. So based on our requirement, you can use the different commands. Let us see now. LCD dot scroll display. So there is no parameters are required. So whatever the parameters already message is there, it will consider that one. So I think this no parameter. I there is an error in this scroll display. Otherwise, we'll use auto scroll. So whenever it is initializing, just you can refresh this one, and you can use scroll display left. Otherwise, we'll directly copy from here. Scroll display right. Okay. I think here display spelling is wrong. That's why it is showing an error. Now you can see it is scrolling left side. Okay. So if you want to scroll right side, we need to change the code as here right. Now you can observe here it is scrolling from right to left. The whatever the display is available, that is. So from this I conclude that I interfaced LCD to Arduino Uno, and I am displayed two messages on LCD. One is RP EduTech in first line, YouTube in second line. Thank you for watching. Please like, share, and subscribe. Thank you.